Next, we are going to start question number 9, which is the easiest sum in this whole exercise. So, in question number 9, it is given that in parallelogram ABCD, 2 points P and Q are taken on diagonal BD such that DP equals BQ. Okay, in parallelogram ABCD, 2 point and BD is and diagonal BD is drawn, and 2 points are taken P and Q such that DP is equals to BQ. So, in given we have written that ABCD is a parallelogram, DP equals BQ. Okay, and I have marked angle 1, angle 2, angle 3 and angle 4 here. So, we have to prove 5 sub sums in this question 9. So, the first sum is we have to prove triangle APD is congruent to triangle CQB. Triangle APD is congruent to triangle CQB. So, we can write, at first we can write that, we have to prove this both triangles equal. So, congruent. So, we can write that DP equals BQ, which is already given. AD equals BC, because we know that opposite sides of a parallelogram are equal and parallel, and angle 1 equals angle 2, which is alternate interior angles. Therefore, we can say that triangle APD is congruent to triangle CQB by SAS congruence criteria. And in the second sum, we have to prove that AP is equal to CQ. We can prove that by writing it as corresponding parts of congruent triangles, that is CPCT. And in question number 3, we have to prove that triangle AQB is congruent to triangle CPD. So, in congruent, the triangles we have to look, AQB is congruent to triangle CPD. We can again write that DP equals BQ, which is already given. AB equals CD, which is, we know that opposite sides of parallelogram are equal, and angle 3 equals angle 4, which is that it is alternate interior angles. Similarly, in that process, these two triangles are proved congruent by SAS congruence criteria. And in the fourth sum, we have to prove that AQ equals CP. We can write it as they are equal by CPCT. In the fifth sum, we have to prove that APCQ, that is the inner quadrilateral, as a parallelogram. We already know that if we prove any one pair of the parallelogram as parallel and equal, then we can say that quadrilateral is a parallelogram. So, from equation 1 and 2, I have proven that AP is equal to CQ and AQ is equal to CP. I have proved that they are equal to each other. So, opposite sides are equal to each other. I haven't proved that the angles are at 90 degrees. So, we can say that APCQ is a parallelogram. Next, we are going to start question number 10. In question number 10, it is given that ABCD is a parallelogram and AP and CQ are perpendiculars from vertices A and C on diagonal BD. Show that triangle APB is congruent to triangle CQD and AP equals CQ. So, we have to write the given, that is ABCD is a parallelogram. AP is perpendicular on BD and CQ is perpendicular on BD, and then we have to prove that triangle APB, that means this triangle and triangle CQD and this triangle, we have to prove these two triangles as congruent. We can write that AB equals CD or DC. AB equals DC, which are the opposite sides of parallelogram. Angle P equals angle Q because they are both 90 degree each, and side PQ equals QP, which is a common arm. Therefore, triangle APB is congruent to triangle CQD by SAS congruence criteria. Then we have to prove that AP equals CQ. We can write that they are equal by corresponding parts of congruent triangles, that is by CPCT. 9 and 10 are also proved. Thank you.